So today we are on lesson 1A, as you can see right here, and we are shifting our focus on the standards to pure 7th grade standards. We've spent the last few days reviewing, adding, subtracting, multiplying, and dividing fractions and decimals, and the reason why we did that is because we're going to need some of that stuff from here on out. And so our focus today is on scale factor and similar figures. So please make sure that you have your packet opened up to this lesson, and then you are filling in the objectives. And so today our daily learning target is you will be able to find the scale factor on scaled copies of figures. And so we'll do some defining of what we mean by those particular things. Our language target, which typically talks about when we do some shoulder partnering, what our focus will be. So regarding that, you'll be able to describe some characteristics of a scaled copy. And I always give you one of many reasons why you're learning this. So an example of that for today might be designing a movie set that is scale to the original set. And as usual, please make sure you have filled in the blank areas regarding those three things. All right, so let's move on. Let's first start by defining a few things. One of the things mentioned in the daily learning target was that of a scaled copy. When we're talking about a scaled copy, we're talking about a figure in which every length in the original figure is increased or decreased by the same scale factor. So we're obviously going to have to define what we mean by a scale factor as well. If there are any blank areas within this definition, please make sure that you fill it in your notes, in your packet. By a scale factor, we are talking about the factor by which an original figure is increased or decreased when you make a scaled copy. So we start with some sort of figure. We are given a scale factor which tells us whether the scale copy will be larger than that or smaller, and by what degree. And it's the scale factor that allows us to do that. So if we get as simple as possible here we have rectangle A that has a width of 12 and a length of 6, or a length of 12 and a width of 6, however you want to look at that. And then we have rectangle B. Now, rectangle A is the original figure. We're going to apply some scale factor to rectangle A to create what we call a scaled copy. Rectangle B is the scaled copy by a specific scale factor. So if rectangle B is 24 by 12, where rectangle A was 12 by 6, that means rectangle A has been increased by a scale factor of 2 to create rectangle B. So if you've got any blank areas anywhere in there, you need to make sure that you fill them in. But the important piece right here is that rectangle A has been increased. Now we say it's been increased because rectangle B is actually larger than that by a scale factor of 2. And really all that means is that if we make the side lengths of rectangle A 2 times as big from the scale factor of 2, we're going to get the side lengths of the scaled copy, or rectangle B. So rectangle A is the original figure. Rectangle B is the scaled copy because we've applied some scale factor to rectangle A to either make it smaller or bigger. In this case, we've made it larger or bigger. Okay, so let's go to number 1. On the top left is the original drawing of the letter F. There are also several other drawings. Identify all drawings that are scaled copies of the original letter F. Discuss how you know. Now we're going to do this one together. So the first thing that we probably should do is to actually figure out the length of each of those line segments that make up the letter F right there. So the top part is 2 units. This part right here is 1 unit. And this part right here is 4 units. So if any of these others are going to be a scaled copy of it, some sort of scale factor has to be applied to it. So let's go with drawing number 1. This part is 3. This part is 1.5. 1, 2, 3, 4, 5, 6. This is 6. So this one looks like it might be, but the question is, what would the scale factor be if that is the case? And let me change pen colors here. If we multiplied this by 1.5, 1 by 1.5, we get this. If we multiply this by 1.5, we get this. And if we multiply this by 1.5, we get this. So what that means is that drawing 1 is definitely a scaled copy of the original letter F. And that's kind of how we have to go about doing this sort of thing. So now let's take a look at the second drawing. Let's see, this is 1, 2, 3, 4. This is 2, 1, 2, 3, 4, 5, 6, 7, 8. So we have to think about this one. Is this one a scaled copy of the original? Think about that for a second. And it should make sense to you that it is, because this times 2 is this. This was 1. This times 2 is this side. And this times 2, 4 times 2 is 8. So this one also is a scaled copy of that. So now let's go through and try some of these other ones here. You should be able to just look at drawing 3 to see that it clearly is not. But even if we didn't notice that, this is 4, this is 3, this is 4. This one is not because 2 times 2 is 4, but 1 times 3 is 3. So that one is not. All right. Drawing 4, it should be obvious to you because it's sort of slanted. Now let's take a look at drawing 5. Drawing 5 looks like it might be, but we've got to do a little bit of figuring here to see if that is. So let me do some erasing here. Just trying to make some room. So this is 3. This is 2. 1, 2, 3, 4, 5, 6. So the easiest one to figure out is this one right here. 1 times 2 is 2. 2 times 2 is not 3. So therefore, drawing 5 is not. Drawing 6, 1, 1, 2. It should be obvious that this one is not, because 1 times 1 is 1 and 2 times 1 is not 1. So this one is not. So now the last one we have to look at here is the last shape here. So this is 1, 2, 3, 4, 5, 6. So that's 2 times 3. This is 3. That's 1 times 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This one is 12. 4 times 3 is 12. So this one also is. So it looks like drawing 1, drawing 2, and drawing number 7 are the ones that are scaled copies of the original drawing. Okay, so I want you to take a look at number 2. Go ahead and pause the video, and then when you think you've figured out which of the figures between B, C, and D are scale copies of figure A, then press play to see if you're right or wrong. All right, so the first thing that we should do here is we should figure out each of those side lengths of that L shape for figure A so that we can then find these missing side shapes for the other ones to see if they are truly scaled copies. So this is 1, 1, 2, 3, 4. This is 4, 2. This is 2. This is 1. This is 3. 1, 2, 3, 4, 5. And this is 5. Well, in figure B, this is 1. This is 1, 2, 3, 4, 5, 6. We should already see that figure B is not, because to get from here to here, we're multiplying by 1. So if it was a scaled copy, Figure B, we'd be multiplying every side by 1. And this times 1.5 is side 6. So clearly, B cannot be a scaled copy. And that's how it should work. We should be multiplying every side by the same value. So now let's check figure C. This is 2. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's looking like perhaps if we multiply each side by 2, it might be. So this times 2 is this. 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 And this times 2 is this. So yes, figure C is. Now I've made a big mess here. I'm going to erase a little bit. All right, let's check figure D. We've got 1, 2, 1, 2, 3, 4, 5. And we can stop right there because this times 2 is that. But this side, 1, 2, 3, 4, times 2 is not 5. So the only figure that is truly a scaled copy is figure C because, as we already figured out, in figure C, the length of each segment of the figure is twice the length of the matching segment in figure A. All right, we're going to do the same thing for figure 3, or number 3, excuse me. So what I'm going to do is I'm going to have you pause, read the problem carefully, and then figure out how you're going to answer that particular problem. Okay, number 3 says, Lucy and Ryan are discussing the figure shown below. Lucy thinks B, C, and D are scale copies of A. Ryan says that B and D are scale copies of A. So do you agree with Lucy or do you agree with Ryan? Discuss your reasoning. So I'm going to go about doing this the same way that I did the previous problem. But this time I'm just going to go ahead and figure out all the side lengths. So here we have 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and 1. This one is 1, 2, 2, 1, 2, 2, 1, 2, 2, 1, 2, 2. And we should see that B is not, because 1 times 1 is 1. And so in order for that to be a scale copy, all of the sides multiplied by 1 would have to be the side length on side B. But we can see that 1 times 1 here is not 2. So figure B is clearly not. All right, so let me go down and try C now. C is 2, 1, 1, 2, and you should already be able to stop right there because of the fact that 1 times 2 is 2, but 1 times 2, or oops, wrong side, 1 times 2 right there is not 1. So C also cannot be. And now let's try D. 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. So it looks to me like if you multiply each of these side lengths by 2, you get all of these down there. So D is the only figure that is a scale copy. But the question was asking if you agree with Lucy or if you agree with Ryan. Lucy thought that figures B, C, and D were scale copies. Well, they're not. Only D is. Ryan says that B and D are scale copies. Well, they're both not. Only D is. So actually, you should not be agreeing with either one of them because only D is a scale copy of a copy of figure A. All right, so let's go to number 4. Number 4 states that figure B is a scale copy of figure A. So figure A is the original. Figure B is the scale copy. What is the scale factor taking figure A to figure B? And these are really very simple because all you're trying to figure out is what do we have to multiply that side by to get this, and what do we have to multiply that side by to get this. And if it's the same, it is a scale copy, and that will tell us what the scale factor is. Well, clearly, it's going to be 4 because 6 times 4 is 24, and 3 times 4 is 12. So that means that the scaled factor, not scaled factor, scale factor is equal to 4. Because once again, we're multiplying each of the side lengths in figure A by 4 to make figure B. And I'll kind of go through it one more time there. And it is 4. So the scale factor taking figure A to figure B is 4. All right. Now notice in number 5, though, figure B got smaller. Or we took figure A and we made it smaller to see figure B. So we have to pay a little more attention to what we're doing here. And in order to make 16 into 8, we would have to multiply by some fractional value. In fact, we would have to multiply by 1/2. 16 times 1/2 is 8, and 12 times 1/2 is 6. So sometimes the scale factor might be a decimal or a fractional value. So in this particular situation, since the shape got smaller, we would know automatically that the scale factor would have to be a fractional value. In fact, we'll realize a little bit later in the lesson, it's going to be some value, some fractional value between 0 and 1. All right, so let's take a look at number 5. In fact, I would like all of you to pause the video and try number 5. So in number 5, you're going to have to find those side lengths. All right, let's take a look at number 6. So the first thing we need to do is figure A is the original, and figure B is the scaled copy. So figure A is 3 by 2, and now the side lengths on B are 6 by 4. So we can see that if we multiply each of the side lengths in figure A by 2, we get the side lengths in figure B. Another thing is this. If the figure is getting larger, which it did, we know the scale factor has to be some value larger than 1. And if you go back to some of the previous problems that we've done, that is what happened, including this one right here. We know the shape got bigger. The scale factor is 2. That is some value larger than 1. Okay, let's go to number 7. Same idea. Pause the video, then press play when you think you have the correct answer. Okay, so figure A is the original. Figure B is the scaled copy. Notice the figure B got smaller than figure A. So once again, we know that the scale factor has to be some fractional value or some decimal value between 0 and 1. So if we just start figuring out the side lengths here, and then finding the side lengths for B, we're going to see that the scale factor has to be 1/2, because if we take each of the side lengths in figure A and multiply them by 1/2, or take half of them, we'll get each of those side lengths in figure B. All right, let's take a look at number 8. Pause the video, press play when you think you have it. All right, now notice in number 8, this is the first time we've seen one like this. Figure B is exactly the same size as figure A. And anytime that happens, when the figures are identical, that means we're taking each of these side lengths in the original figure, figure A, and multiplying by 1, and we get the values or the side lengths in figure B. So if the shape stays the same, in other words, if the original and scale copies are identical, the scale factor would be 1. And that leads us into our next thing. For each of the following, figure B is a scaled copy of figure A. State whether the scale factor is between 0 and 1, which, remember, means that the shape is getting smaller, or if it's 1, means they stay the same, or if the scale factor is greater than 1, which means the shape got bigger. So you're picking either A, B, or C. Between 0 and 1, 1, or greater than 1. And in fact, I'm only going to give you just a few seconds to try this one. And clearly, since figure B got larger, it means we have to pick C, greater than 1, since figure B has been scaled larger than figure A. So a quick review of that idea. If a figure has been reduced, the scale factor is between 0 and 1. If the figure has been enlarged, the scale factor is greater than 1. And if there is no change to the figure, the scale factor is 1. If you have any blank areas in your notes, you'll need to make sure that you fill those in. And as soon as you get those filled in, then I would like you to go ahead and do the next 3 problems. Actually, next 5 problems. Number 10, 11, 12, 13, and 14. Please do all 5 of those problems. So pause the video and then do all 5 and then press play when you think you have it. All right, notice we start with figure A. We made it smaller to make figure B. That means we know the scale factor has to be some value between 0 and 1. So maybe like a half or a third or something like that. Number 11, notice that the shapes are identical to each other. That means the scale factor is 1. Number 12, we've got these parts of a circle. We tend to call those sectors in advanced math classes. But notice the shapes are identical to each other for number 12. Therefore, that would be equal to 1. Number 13, notice that figure A got smaller to create figure B, or larger, not smaller. That means the scale factor has to be greater than 1. And it is 14, where figure A, we made it smaller to create figure B. Or in other words, figure A got smaller. And that means the scale factor has to be somewhere between 0 and 1. All right, last idea for today. What if we're given a shape, we're given a scale factor, and you're supposed to recreate the shape? So in number 15, it says you are to apply a scale factor of 3. So the first thing that we're going to have to do here is we're going to see, as far as the shape that's already there, what the side lengths are so that we can then apply the scale factor. Well, notice that this shape is 5 by 5 by 5 by 5. So now we're going to create a shape that is a scale copy of that one with a scale factor of 3. So if the scale factor is 3, it should be obvious to you that the new shape that we're about to draw is larger than that one because the scale factor is greater than 1. And the thing that you have to pay attention to when you're doing these problems in MyOpenMath Math is you have to follow the directions. Start at the blue vertex. That's the blue vertex. A vertex is a point. So we're going to start and end at the same shape. So if we're applying a scale factor of 3, 5 times 3 is 15. So that would be this. And it'll come out to be a lot neater in MyOpenMath Math. We've got 15 here also. And 15 right there. And then 15 back to where we started. That's what the scaled copy should look like. So the purple one that I just drew, that is the scale copy because we took the original, the one in red, applied the scale factor of 3, and since it was 5 by 5 by 5, this one ends up being 15 by 15 by 15 by 15. So let me take off my big mess here and draw it for you a little neater. All right, let's go to the next problem. Everybody read number 16, press pause, draw it, and then press play to see if you got it right or wrong. All right, so for number 16, notice that we are applying a scale factor of 1/2. That means we have to take that red triangle there and make it smaller. Why? Because the scale factor is some value between 0 and 1. 1/2 is between 0 and 1. So what we should notice is that this is 5 here, and this is 6 here. We don't really know anything about this, but that's not really. Okay, I may be repeating myself, but I don't know whether I pressed pause or play when I was recording. So once again, what we know about number 16 is that we have a scale factor of 1/2. That means we're going to take this red triangle and make it smaller. Why? Because the scale factor is some value between 0 and 1. 1/2 is between 0 and 1. So what we need to do here is we need to say, well, this side length is 5. This side length is 6. So we have to make those half as big. Well, half of 5 is 2.5. So remember, we're going to start here. And then half of 6 is 3. So we're going to go right there. And then we will connect everything together and end at the original starting point. And there, let me take off my mess here. There is a right triangle in blue that has a scale factor of 1/2 when we compare it to the original red triangle right there. Notice that it is smaller. Okay, so the next problem is just more of the same. I think I'm just going to zip through that one really quickly. I'm applying a scale factor of 2. Notice that each side length is twice as big. And we end every day the same way. Let's think about what you learned today. Take about 15, 20 seconds to think about that. And what you should have thought about was really 2 things: creating scale copies and the idea of scale factor. And that is it for today.